Hello, welcome all. This is Dr. Vinay Domal from South Metro TAFE. I've been working as a lecturer mainly in the area of civil structural design and mechanical engineering mainly. Today, I find this opportunity to explain some of the future way of engineering design and cloud platforms that we are going to discuss today, which allows a much more collaborative and authentic, basically training and the teaching environment. I will discuss some of these opportunities, compare what's the existing platforms that we have, especially with the desktop, the challenges that we have, and how we can improve the teaching so that it brings a more reality into what we design, especially. Okay, so those who don't know about the engineering CAD softwares, they assist engineers in designing, drafting parts, assemblies. That includes, structures, and they could be done in 2D, 3D. There is a different requirement. Sometimes you just need 2D, but sometimes you need a 3D model, solid models, much more geometrically correct models, for inspection to make sure that it fits into another assemblies, and create a whole system basically. Now, some softwares they go quite deep into every branch of engineering, so you can have electrical, electronics, structural, mechanical, civil. Systems includes electrical, plumbing, and so on. So these softwares, they allow for you to solid models, surface model, simulate, including automation, and also dynamically analyze the models, and also to generate a geometrical design for manufacturing. If you want to fabricate it, if you want to prototype it, it's much easy with the engineering CAD softwares, and they've been in the pipeline for ages. Maybe we are looking like 40, 50, 60 years maybe, since the computer started to come into picture, manufacturing, especially with the automobile design. That's where the innovations come through, and also the forefront in the military and also the defense. They've seen the importance of these softwares, design softwares, where they want to get rid of the paper-based type of drafting or design spaces. Then today's session objectives I want to be clear on. We evaluate the current flow of the engineering design, basically using the desktop softwares, and also we discuss the future options, and I will try to demonstrate today some of the working examples which shows the future of the collaboration. Let's see the traditional softwares, disadvantage with them. Sorry, my apologies. You can avoid basically time and effort required to download the softwares, including the cost of purchase of educational versions. So see, that could be an advantage basically for the cloud, but here you're spending a lot of time, effort to download the software. Then also the purchase of the educational version is not dearer for the students, or not even for the researchers or the trainers. Desktop applications requires high memory graphics cards, processing speed for complex applications. So sometimes we got to get the specifications right. If not, the training environment won't be much suitable for the need it is actually catered for. And also with the document management, file sharing, as you know, the students, they, or with the assessor, sometimes we lose these files, and also we want to share these files with the rest of the group, rest of the team. It becomes quite cumbersome, quite complex. In terms of verification and validation, this is what much more close to reality, or you can say it's much more. If in case if you want to do all the checks and all the interferences within the model, and also with the different teams, it is time consuming. And when we create a project with project-based environment and project-based learning, when we try to create multiple teams, then electrical or team wants to check how much space they have to put their PCB or a motherboard in a particular product, then it becomes a challenge, so that they got to go and find these files, where these files are there, and how much space or a geometry, so that they can work through their own design and put through. So that sort of customization, is not possible in the traditional desktop software. It's still an advancement. What we see the in terms of the time. There is a lot of power in terms of the CAD softwares, but you will see some of these can be reduced with the new cloud-based platforms. So you can access anywhere you want, anytime you want. You can even look at the model, do your review on your smartphones, because every student now does have smartphones. There is no installation is required, no hassle of ICT and schedule maintenance reminders, because it becomes a challenge for the trainers to remind the management, to remind the ICT that there is a current version. You go and update it. Students have a problem with that, and the compatibility issues. Student at home, they have a different version. Especially these softwares, they think majority of their design to limit their market conditions, and we can't imitate that in the education. We are limited by time, so all this becomes quite easy when you have a cloud-based platforms, and also the learners, they come up with their own version of their laptops. They want to work on a Mac, they want to work on Windows. I've seen these issues a number of times, and it becomes, when a student is very good, technically challenging, and he wants to work through it, some of these will put him away. But again, you got to come back physically. It limits the students to come to a campus and work on it, work with the team and so on. But it could have done completely online. Optimizes the design workflow. Then you can blend with the tech teams, which I was talking earlier about, lean mentality of the product team, design thinking of design team. So you can see all these advantages when you have one independent platform. Someone manages it for you. There is no cost for you. All you need is to make sure that you pay or get access to that online platform. So we'll see here some of the SolidWorks 2020 features. So I will go to the browser. So the browser, this is what you have. Either the trainer or the students will have something like this. And what you do is you log in basically, and click on launch, and it tends you to launch into the current version. And all you need is to find a specific file, work through the file as it loads. Find the particular assembly, find a particular part, do your changes, do your TQs, technical queries, whether it's requested by the team within, or the internal or the external collaborative team space, and work through the model. So you can click on it. So let me find the file. So this is the assemblies. I created a structural system here. So that's your shed, and from shed means basically it's a single portal frame. But what you can do is you can make an assembly from here. This is everything. I'm doing it on the browser. So make an assembly from the part. So you can insert. Once you insert a component, you can basically view the component isometric, and what you want is basically to create some linear pattern of the portal frame. So I'm selecting the structural system. And along the typical edge that I want to pattern, and increase it by, so give some distance in them and increase the number of frames that you want, and say yes. Sorry, I selected the component. So selected the components, then created the pattern. So you can see, but if the model is done in a pattern like this, and say for example with the portal frame, if you're not happy with the pattern, or if you're not happy with the distances, sometimes there's specific distances you maintain depending on whatever the analytics you have done, depending on the type of loads that you have in the model. But once you have that geometry generated as a pattern like these, then what you can do is simply go here into the file options, tool options, and what you can do is you can invite people by collaboration and enable multi-user environment, and basically you can create some shortcut and click OK, and what it allows you is that that this file could be shared with the multiple people, and they can be there to edit distance, for example, with this particular pattern. If you're not happy with the offsets that you have created, so people can come on board from here. You can share this particular space to a Dropbox, and create a Google Drive for it, and you can also use the other two multiple libraries, design libraries, and these design libraries could be again a third party external, but you can evaluate this particular product in collaboration with the people being online, then in a way to check these interferences, check the clearance verifications, and also to do some studies, in terms of design studies. If you want to do a design studies, you can do a design studies, but this is all happen online with multiple teams working on a very simple design aspects, but it can become very complicated as well. That's the advantage, that's the beauty of these tools when they become in terms of its details. It challenges you to make sure that these multiple teams accept that this structural verification is okay, because next day the envelope is going to come up, either concrete is happy with the connections, for example, either the steel detailer is happy with the details that you have within the model. Some of these aspects could be quickly verified on the go, and you have a model ready for the end user, ready for the manufacturer to go ahead with the design, to go ahead with a very current design and fabricate it, assemble it, and this can be create a complete workflow of how to assemble, how to install, and so on. So some of these aspects that you see in future, what we are talking about, being more authentic, being more real, and also the context that you want to capture could be easily done by these tools. I hope you enjoy my presentation. In the end, I will add a couple of survey questions. If not, you can just put a comments on my the subscription or on the YouTube. Thank you very much.